A very good morning once more to all of you again. Okay, so let us continue the chapter
Thank
8,
God.
organic chemistry. So, in my yesterday's class, I was talking about the physical properties of alkenes, and today I'll be discussing and teaching you about the chemical properties of alkenes, and that alkene which I will discuss is called ethene. So, chemical properties of ethene. I will discuss this today. Okay. Now, ethene, it is an alkene containing a carbon-carbon double bond. That is why it will undergo addition reactions easily. They undergo addition reactions easily. Okay. Now, the first type of reactions which ethene normally undergoes, it is called addition reactions. Alkenes undergo addition reactions. Alkenes undergo addition reactions. This is the type of reactions undergone by alkenes, and the alkene which is to be studied by us, it is called ethene. The molecular formula of ethene you already know, it is C2H4. It is C2H4. Now, under the addition reaction, there are different categories over there. The first one, the first addition reaction which I would like to discuss, it is called catalytic hydrogenation. It is called catalytic hydrogenation, means addition of hydrogen in the presence of a catalyst. So that is number one, which is called catalytic hydrogenation. This is the first type of addition reactions generally undergone by ethene. So the equation is here, H2C double bond CH2. This is how we write the structural formula of ethene. Ethene. Now when you react this ethene with hydrogen gas in the presence of a catalyst, nickel catalyst, at a temperature of 300 degrees Celsius, then the double bond breaks into a single bond, okay, and two hydrogen atoms attached to each of the carbon atoms in the ethene molecule. So we get H2C, one H over here, the double bond becomes a single bond, another carbon, H2, and over here hydrogen. So this is ethane. So this is how we can convert. You can convert ethene and alkene to ethane and alkane. So this reaction is called catalytic hydrogenation. Now remember, this ethene is unsaturated. It is unsaturated. It can still contain more hydrogens, but ethane is saturated. So when we pass hydrogen gas through ethene in the presence of nickel catalyst at 300 degrees Celsius, then ethane is formed. Okay, so this is the first type of addition reaction normally undergone by ethene. Then next one, number B. The next addition reaction is called halogenation. It is called halogenation. Halogenation means addition of halogens. Addition of halogens. Which halogens? Over here, the halogens could be chlorine it could be bromine, it could be iodine. Okay, so this could be the halogens which can be used for the addition reaction, for the halogenation reaction with ethene. So the examples are here: H2C double bond CH2, that is the ethene. When it is reacted with chlorine gas Cl2 in an inert solvent like carbon tetrachloride. This carbon tetrachloride, it is a solvent, it is an inert solvent. It is an inert solvent. So in the presence of carbon tetrachloride, which is acting as an inert solvent, chlorine reacts with ethene to produce a compound which has a formula like this: H2C, single bond CH2, and then one chlorine here, another chlorine here. So this compound is formed after the addition of chlorine, and this compound, it is called, according to the IUPAC nomenclature, it is called 1,2 1,2 dichloroethane. 1,2 dichloroethane. Okay. Then instead of chlorine, if I can use bromine also. I can react even bromine gas with ethene. So here I'll write ethene, the formula, structural formula of ethene plus bromine, Br2, again in the presence of the solvent, inert solvent, CCl4, inert solvent, it produces bromoalkane, a dibromoalkane. So one bromine, one carbon, another bromine atom, another carbon. So this compound, it is called 1,2-dibromoethane. It is called 1,2-dibromoethane. Okay, so this is the reaction of bromine with ethene. So there is breaking and making of bonds, breaking of double bond and making of new bonds. Okay. Then the next example is reaction of iodine with ethene. Here also I can do this way. I can write down the formula of ethene, H2C, CH2. This one is ethene. Plus I can react it with iodine, I2. Okay. In the solvent, inert solvent, that is carbon tetrachloride, then I will get H2C, I, CH2I. So this compound, it is called 1,2 diiodo ethane. Okay, so these are the three examples of halogenation reaction with ethene, the alkene. Okay, then the next type of addition reaction is reaction of halogen acids. Reaction of ethene with halogen acids. That is number C. So I'm going to write it down. Reaction of ethene with with halogen acids. Halogen acids. Acids containing halogen. So examples could be hydrochloric acid or hydrobromic acid. These are the good examples which can be used to react with ethene. So the equations are H2C. The equations are ethene molecule. I'll write down first. H2C, H2C, double bond CH2. This is ethene. I am going to react it with hydrobromic acid, HBr. It is hydrobromic acid. Okay. Then over here, one hydrogen goes to one carbon. After the breaking of the double bond, the bromine goes to the other carbon. So we have the compound which is formed. It is like this: H2C, one hydrogen here. The double bond is breaking into a single bond, and then CH2 over here, Br. So this compound, it is called bromoethane. It is called bromoethane. So this is the reaction of the halogen acid, hydrobromic acid. This one is what? It is hydrobromic acid. Hydrobromic acid. Like hydrochloric acid, it is also hydrobromic acid. The other reaction is for the reaction between ethene again with hydrochloric acid, H2C, double bond CH2, that is ethene, with hydrochloric acid, that is HCl. Okay, so again, the reaction happens in a similar pattern. The hydrogen goes to one carbon, the chlorine attaches to the other carbon. So we get a compound over here, H2C, hydrogen here, double bond breaks into a single bond to give CH2, and then over here Cl. This compound is called chloroethane. It is called chloroethane, Ethane, because carbon carbon it is a single bond. Now say for example, if I catch hold of this chloroethane, if I catch hold of this chloroethane, say I will write the formula CH3 CH2Cl, chloroethane, and react this chloroethane with say potassium hydroxide solution, aqueous potassium hydroxide solution. Now, this is an example of hydrolysis. Hydrolysis happens where this chlorine gets substituted by the hydroxyl group from potassium hydroxide, where I will get CH3 CH2OH plus potassium chloride is formed. So this reaction which I've written down over here, it is it can be used to prepare an alcohol. This compound is an alcohol. The name of this compound is ethanol. It is called ethanol. And this reaction, whenever we react aqueous potassium hydroxide with alkyl halide, chloroethane is an alkyl halide. So the reaction it is called hydro. It is called hydrolysis. Hydrolysis. Okay. Then the next addition reaction, that is number D. That is number D is reaction of, which is important. Okay, this is important. Reaction of ethene with conc with concentrated concentrated sulfuric acid. Reaction of ethene with concentrated sulfuric acid. This reaction. So here over here H2C, again I react H2C CH2, that is ethene with conc sulfuric acid. So sulfuric acid I'll write down in this manner: H dot HSO4. It is the same thing. Okay. So here again what will happen? This hydrogen goes to first carbon, the remaining goes to the second carbon. So I have a salt over here which is produced. That is H2C, the double bond breaks into a single bond, and then this is what we see, CH2 HSO4. This compound is called ethyl 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 hydrogen sulfate. It is called ethyl hydrogen sulfate. This compound is called ethyl hydrogen sulfate. Okay. Now this ethyl hydrogen sulfate, conduct hydrolysis, if you conduct hydrolysis means reaction with aqueous potassium hydroxide or aqueous sodium hydroxide, if you react it with aqueous sodium hydroxide or aqueous potassium hydroxide, then this ethyl hydrogen sulfate will give us an alcohol. So it will produce an alcohol CH3 CH2OH. This step it is called hydrolysis. It is called hydrolysis. So this is how we can also prepare alcohol from ethene by reaction with concentrated sulfuric acid. Okay. Then the next one, number E. Next one is number E. Reaction of ethene with ozone. Reaction of ethene. Reaction of ethene. Ethene with ozone. You must have heard of the ozone layer. Okay, the formula, the molecular formula of ozone, it is O3. It is O3. The molecular formula of ozone is O3. Okay. If you talk about the structural formula, then structural formula is something like this. Okay. Structural formula of ozone containing 3 oxygen atoms. Now, if I proceed to write down the chemical reaction, then the chemical equation is like this: H2C double bond CH2. This is ethene reacting with ozone. The reaction must be carried out in ether, in a medium of ether, diethyl ether. Okay, a solvent, inert solvent. Ether is an inert solvent. It is an inert solvent. So, in the presence of ether, which is inert solvent, ozone reacts with ethene. Okay, to break the double bond completely. The double bond between the two carbon atoms is broken completely. Finished. It is broken down very badly. And then in between the two carbon atoms, there is a link H by an oxygen atom, like this, like this. This is what happens. This is what happens. Now this compound which is formed, it is an intermediate. This compound it is called ethylene ozonide. It is called ethylene, ETHYLEN, ethylene ozonide. Ethylene ozonide. Now what is the use? This ethylene ozonide has a very important use, because if you further distill this ethylene ozonide, if you distill it with zinc distillation, if you distill it by using zinc, then this ethylene ozonide gets converted to aldehyde. It gets converted to an aldehyde. So two molecules of aldehyde is formed. So this is how the bond breaks. This is how the bond breaks over here, and then it forms uh, HCHO, that is aldehyde, another molecule HCHO. Okay, so zinc combines with this oxygen to give zinc oxide as a byproduct. So here ozone, when reacted with ethene, it produces ethylene ozonide, a cyclic compound. A cyclic compound. Now this cyclic compound, upon distillation with dry zinc, heated, heated with dry zinc, it gives two molecules of aldehyde. Aldehyde. This is the correct IUPAC name is methanol. It is called methanol. Methanol. This is also methanol. Methanol. Okay. And the nickname, the common name, the nickname for methanol is, it is called formaldehyde. Formaldehyde. It is called formaldehyde. Remember that. Okay. So this is what happens when ozone reacts with ethene in an inert solvent like ether. Okay. Now here you can see this word ether. Example of ether I can write down: CH3O CH3. This is dimethyl ether. This is dimethyl ether. Dimethyl ether. Another example I can give you is C2H5O C2H5. This is diethyl ether. Diethyl ether. Diethyl ether. Now this ethereal compounds, they are used as a solvent to conduct this reaction. Okay. So this was number E addition reaction. The fifth addition reaction of ethene with ozone. Okay. Now the next type, it is called oxidation. Oxidation of ethene. That is number F. Number F on your screen you can see oxidation. Oxidation of ethene. Ethene by using cold and dilute potassium permanganate solution. Oxidation of ethene by using cold and dilute potassium permanganate solution. Okay. So here, if I add cold and dilute potassium permanganate solution, this cold and dilute potassium permanganate solution, this is called as reagent, a Bayer's reagent. It is called Bayers. It is called Bayer's reagent. It is called Bayer's reagent. Remember that. Okay. So next time I talk about Bayer's reagent, you should immediately recall that it is actually cold and dilute potassium permanganate solution. Okay. So here the equation goes like this. Ethene molecule, structural formula, CH2CH2. Okay. Now this cold and dilute potassium permanganate solution is going to provide me with water. So there is water, HOH. It is an oxidizing agent, so it is also going to provide me with nascent free atoms of oxygen. So under these conditions, so this much it is provided by whom? This is provided by cold and dilute potassium permanganate solution. Water and nascent free atom of oxygen. So this is going to combine after breaking the double bond into a single bond and going to form what? One OH is over here, another OH is over here. So these two OHs are going to combine to each of the carbon atoms in the ethene molecule by breaking the double bond. So it forms like this: H2C, single bond, CH2, and then there is an OH over here, there is an OH over here, the hydroxy group to both of the carbon atoms. And this compound is a very, very important synthetic product which is prepared by using organic chemistry. This compound, it is called one to two carbon atoms, so it is called ethane dash 1 comma 2 diol. Two times alcohol, so diol. Now this compound, it is used as a coolant in the radiators of four-wheelers. It is used as a coolant in the radiators of four-wheelers. Okay, so this is how you prepare ethane 1,2-diol. Ethane 1,2-diol, it is also called, nickname is, it is also called ethylene, ETHYLEN, ethylene glycol. Ethylene glycol, the trade name. Okay, ethylene glycol. Okay. Now, under this oxidation, I can also talk about combustion. I can also talk about combustion reaction. Now the combustion reaction means burning of ethene in oxygen. It's a hydrocarbon, we know. All hydrocarbons, they burn in sufficient oxygen to produce carbon dioxide and water vapor. That is true. So if I take ethene, that is C2H4, and burn it in oxygen, it is going to give me carbon dioxide gas and water vapor. Along with this, a lot of heat energy is also given out. So it is an exothermic reaction. But here the question has been asked, what is the color of the flame? when ethene burns in oxygen. So the color of the flame, it is a pale blue flame. It is a pale blue flame, which means to say that ethene, ethene, ethene burns in oxygen with a pale blue flame. Ethene burns in oxygen with a pale blue flame. So, so this were the oxidation reactions of ethene, oxidation and combustion. The next one, the next addition reaction we can talk about, what we call, that is polymerization reaction. The next chemical reaction is called polymerization. Polymerization, polymerization reactions of ethene. Now, what is polymerization? I'll tell you. Now, polymerization, it's a process by which simple molecules join, they join to form large molecules at high temperature and high pressure in the presence of certain catalysts. Catalysts are necessary. So here, if I take n, large number, n means any number, higher number, more than 5, 6, 7, 10, 20, 30, like that. Okay. If I take n molecules of ethene, H2C, double bond CH2, okay, this is n molecules of ethene, and I subject it to high temperature, I subject it to high pressure, okay, in the presence of a catalyst, like maybe hydrofluoric acid or what you call a sulfuric acid, a suitable catalyst, okay, in the presence of a catalyst, then this ethene molecules, n number of ethene molecules, they will polymerize. But to polymerize, the double bond must be broken into a single bond. So that's how we get a compound, a polymer chain, long chain, H2C, CH2 dash, bond closes here, and then N. If I have taken over here 30, then here I have to write 30. There will be 30. That means if I have taken over here 30 molecules of ethene, 30 molecules of ethene. So under these conditions of high temperature, high pressure and catalyst, I am going to get 30 small units of this compound over here, which is ethylene, after polymerizing. So I can write the condensed formula in this manner: H2C, CH2 dash, and then over here instead of N, I must write over here 30. That means there are 30 units in this polymer. So this will be called polyethylene, plastic, polythene, polyethylene. Okay, so that is how we prepare plastic. It's an important polymer. Okay. Now, after this, moving to the next part of this chapter, that is under this ethene only, we come to the uses. We come to the uses of what we call ethene, uses of ethene, which is important for us to remember also. Okay, today in the syllabus. So, if we look at the what we call uses of ethene, uses of ethene, I'll just discuss them point wise briefly. The first one, ethene, it is used to, after mixing with oxygen, no, it is used to production of oxy oxyethylene torch. Ethylene torch. Now, what is the purpose of this oxyethylene torch? This oxyethylene torch, it is used for what? Welding and cutting of metals. Welding. It is used for welding and cutting of metals. Cutting of metals. Welding and cutting of metals. That is the first use of ethene, to produce oxyethylene torch, because this, the flame which is formed because of this torch is very high, above approximately 3000 degrees Celsius. The next use for ethene, it is ripening, artificial ripening of green green fruits, green fruits. So the artificial ripening of green fruits can be, fastened. It can be made at higher speed by using this gas ethene. Okay. Then the next use is, of course, which you have seen in the chemical properties. It is called catalytic hydrogenation. Catalytic catalytic hydrogenation. Hydrogenation. This catalytic hydrogenation, it is used where? For hardening of oils. Refined oils. No, they are in the liquid state. But if you pass this ethene gas to the refined oils, okay, in the presence of hydrogen and a suitable catalyst, then those refined oils, they become solidified. What you call vegetable butter. Okay, so this is used for hardening of oils. Catalytic hydrogenation, it is used for hardening of oils. The other uses are in manufacture of chemicals like manufacture of chemicals like you can talk about ethylene glycol, ethylene glycol, which is an antifreeze. Okay. As a solvent, manufacture of diethyl ether. I was talking about that. Diethyl ether. It is a solvent. Okay. Manufacture of fumigant. Ethylene oxide is a fumigant, and mustard gas also. Mustard gas. Mustard gas, which is used in chemical warfare. Other other things which can be what you call produced from this is polymers like polythene. I've talked about polyethylene, ethylene, PVC, and so on. Okay, so these are some of the important uses of ethylene which you should try to go through and try to remember. Okay, because this question will be definitely asked in the compulsory part. Am I clear? Now, now
Yes, sir.
it is almost time. So I will not start the next hydrocarbon today because I will not be able to start it properly. That is alkyne. I will do that in the next class on not Monday, on Tuesday. Okay, so I would like to stop my class here only, but before that, just hang on over there because I need to record your attendance. I need to record your attendance digitally, and then only you may leave the class. Okay. So, and on Tuesday,
Thank you, sir.
yeah, don't thank me just now. Remain in the class over there. Okay, because I have to record attendance. After thanking, if you bunk, then it is a bad luck. Okay. Can you see your screen now?
Yes, sir.
Okay.
Sir,
Nikanor, do you want to ask any question?
Sir.
No question. Okay. So anyway, I have recorded the attendance. Okay. Uh, thank you so much. Have a nice day. Please revise.